Hey friends, I just watched the entire Artemis 2 mission supposedly go around the dark side of the moon, and there was a solar eclipse, and things just got a little wacky. So I'm gonna show you the highlights and let you decide for yourself. I'm also gonna show you the comments because there are quite a few skeptics and a couple of people who were trolling very suspiciously as well. So check it out. Let me know what you think. Enjoy. Have
Literally right now on Carpe.
Will mute the entire voice stream. So, guys, this is really great view. We are seeing the sun coming up. There is no voice coming from.
Those first communications back with the astronauts aboard Orion. Christina Cook calling back to what she said just before translunar injection burn, that with this burn, we do not leave Earth, we choose it. The translunar injection burn served as not only what put them on this trajectory to fly around the moon, but what also committed them to splashing down in the Pacific Ocean on flight day 10. At this time, the crew is entering an observation break. We expect this to last about an hour, and it's probably a welcomed break following their very busy day taking pictures, making annotations, making audio recordings, and communicating all of the wonderful things that they are seeing on the moon. This observation break is also partially due to the fact that we will be entering an eclipse later. This will be the first solar eclipse that humans have seen from the moon. The astronauts will need to wear eclipse glasses for the first 2 minutes until the sun is completely covered by the moon, and then they have additional targets that the science team is hoping that they will photograph. We will have communications with them during that eclipse time frame.
Oh wow!
That
Get
eclipse,
it.
Orion's attitude
They
must change
explained
right now
so much
that its
about.
solar arrays are in the sun. This will help it charge the batteries needed to power it through that eclipse time frame. This view on your screen is a visualization. The spacecraft now 4,224 miles away from the moon.
Anthony,
that
thank you.
Will now continue to grow.
Thank you so much.
Of distance from Earth, 252,699 miles, will continue to shrink all the way until our crew is back home.
Thank you. Thank you. That's not real. I was thinking like, how come it was so controlled lighting, right? So, yeah, it should be dimming or blinding our cameras.
Again, we are MET, mission elapsed time, 5 days and 58 minutes since the launch of Artemis 2.
Oh, they put like their backs to it.
We have reestablished communications with the crew and the Orion spacecraft, now entering a little bit of a break while they are out of visibility, or the moon is out of their visibility. The spacecraft will be reoriented to view the moon ahead of an upcoming eclipse. This current attitude maneuver helps charge the solar arrays and batteries aboard Orion that will power them through the eclipse.
Integrity, Houston. In mission control, all of your flight controllers and your flight director have flipped their Artemis 2 patches around. We are earthbound and ready to bring you home.
Oh, wow. So when the patches are up, they are going. When the patches are down, they are coming home. That's very interesting to know.
See the light of day as we head back to.
Yeah, we should have bought some patches for everyone, right? So the speed is finally increasing. Yeah, because of the closeness to the closeness to the moon, I think they slowed down. But now when they get to do the boomerang, they will increase the speed. Or maybe intentionally they slowed down just to get a better view of the moon, I guess. So we are all waiting as we speak for the crew to get the signal back. The crew barely talked when they were getting the signal back. The cosmic ray logo patches, yeah, we need some, whenever we do these things.
A very special moment just now in Mission Control, ahead of the crew's flight to Kennedy Space Center, and during one of their last sims or simulations here, they visited the Mission Control team in Artemis Mission Control in Houston and brought us each a patch. Everyone in the flight control room has had these on their signifiers at their console. On one side of the patch that you've probably seen is the moon with the Earth behind it. Now that we've passed behind the moon and we are returning home, the flight control team has instructed everyone in the room to switch their patch around so that the Earth is closer and the moon is behind us. We are really looking forward to seeing the Artemis 2 crew. And the Capcom, Jenny Gibbons, did call that update up to the crew that the flight control team here has turned their patches around, as was instructed by the crew during that last sim. And we are counting down the days until they get home. They are now 5 days, 1 hour, and 3 minutes mission elapsed time into the Artemis 2 mission.
Very interesting. Very interesting. Looking at those patches, you wanted we should order some patches, folks. Right now I'm into that one. We have to have a brand for sure. Yeah, this view, the one that you are looking at, is showing the distance is now 4th. Yeah, look at this. I'll show you guys this one. So look at this. Look at this distance. So distance to the moon, right? Can you see it? Yeah, distance to the moon. This window is always a tough one. We had a window there, right? What happened to that window? Give me a second.
Joining me here in the room, Artemis Mission Control, I have Angela Garcia, Artemis 2 Science Officer. Thanks for being here, Angela.
It is an honor to be here. What a day. Everyone's been buzzing. I can't contain myself. So it's been a really awesome day.
So you're sitting on console at the Science Console now. Have you been in the SIR earlier today?
There's a lot going on. So I went here first, then I'm going to go there after.
Clear, Houston.
All right, Integrity, we hear you. That was a little clipped, but I think we have a better link now. We experienced some blockage from a solar array. We moved it, and we are in bias tail to sun.
Yeah, so you see this, the distance is now increasing from,
Houston, you're coming in loud and clear, and copy. We're in by
so far it's been decreasing. Now it is increasing. So they're coming home.
A-firm and integrity, just so you know, we did not hear your response once we flipped our patches. Jeremy, we heard you call down, but you were...
So this is going to decrease now. The 653 is going to go down.
Okay, copy that.
It's
we were just
647
excited
now.
that we got to share in that you, the MER, and Mission Control flipped your patches around, and that side of the patch is getting to see the light of day. Thanks for sharing that with us.
Our pleasure.
Okay, Angela, so can you tell me a little bit about your role supporting Artemis 2 and the science preparation for the mission?
Yes. So I'm one of the 3 science officers. So Kelsey's been on console all day. I'll take over kind of closer to the end of the day. And then Trevor Graff is on the planning shift. And so it's a 3.
So I just muted them. Bob, I believe you are saying you are silenced by a different channel for pointing out that what I conceived as a tech issue, not understanding why I get so much better images with a $2 telescope over 100K miles away. I don't think there is anything wrong what you are saying. I think with your cell phone, you get a better picture than what you are getting there. Yeah, I mean, they physically are there, but they are using this tiny camera that is sitting on top of this solar array to capture a blurred image that's not even focused. So unfortunately, that's what you're dealing with. So it's technical problem, I guess, right? And thank you for your support. Thanks for joining the team. Appreciate you being there, and also thanks for your donation. Thank you. Sylvia, thank you for joining the channel. Thank you as a member. All right, we'll be back.
And operations is, I'd say, inherently has more structure and rigidity. And so to marry the two and to operationalize the science that we want to get done has been a challenge. But I think we've been able to go through these processes and create good products at the end and have a good plan. And yeah, it's been really great. What was the second part of your question?
Just what kind of these science activities that they're performing, which of those have you really had a hand in?
Yeah, so a lot of the procedures help organize what the crew is doing in the cabin. And I know we've talked a lot about, what they've been doing, and they've been doing a lot, and it's been a little dark, so I can re-explain what some of those things that they're doing. So the observation blocks are about an hour long, and the crew is organized, the 4 crew members are organized into 2 pairs of 2, the window team and the cabin team. And the lunar targeting package that you've been showing up and that the crew have.
Bob, thank you for joining the channel. Thank you.
It's really the instructions for the window team. So the window team, the 2 crew members are looking out the window. One has the camera with the long lens. One has they're
patch
just
poll
looking
is
out the window
going
with
on.
their unaided eye, and they're taking these detailed observations. And then
We will
in
take
that observation block,
the
they do
3-eye
the
atlas
window team,
picture.
Position swap.
You know
So that's
that
what Capcom's been calling out.
we have
And they'll
2
switch positions, so each crew member
very good
has
pictures
a chance to
now
have that long
competing
lens.
with each other.
And then that's just what the window
And
team
we'll
is
take
doing.
both the
There's
pictures
also
and
the cabin team, where they
we'll
also
we'll-
have duties
we'll
that they're
create
doing.
patches and
We're asking a
t-shirts,
lot
that's
of the
for
crew
sure.
in this time. And then the cabin team, they have the interior camera, and they're taking images inside the cabin. They're also supporting the window team, where, you've heard some call outs where looking out at the bright moon and then looking inside the dark cabin and looking at their LED screen is a lot. So the cabin team is also helping support, target, and guide the window team into specific targets on their plan. They're also helping call out these science situational reps. So they're looking out a different window and listening in to what the crew who are really really down and in the science on the window team are doing, and they're giving us insight. And those recordings that the window team is doing are going to be uplinked or downlinked overnight, and we're going to be able to chew on that data. But yeah, they're helping. They're doing a lot. And so making sure we have a plan that's flexible, but also make sure that we check off all those boxes was really important.
So tell me a little bit more. You talked earlier about the analogs that the crew has done. What kind of analogs or environments were really useful for this?
Yeah, so for procedure development, right, you have so many different environments that you can do. You have classroom, like we said, you have the Orion mock-up, you have simulations, and at least for developing the plan, we kind of did it in a tiered approach, because each of those different analog environments helps us answer a slightly different question and has a little
do
bit
it
of a higher
yourself
fidelity.
series. Thank you.
Write that down and then just keep iterating on that, and then
Integrity Houston for a tag up pre-forward link LOS in place of the Flight Director Conference.
Oh, so they have a flight director conference now?
Okay, Jenny, we're ready.
All right, crew, I'm going to roll through a couple of topics here. The first two are for timeline. First of all, read for your toilet maintenance. It is a shortened toilet maintenance where you do not have to do the oxone changeout. That portion of the procedure is canceled. Victor, you have an HHP stop activity on your timeline. We need you to perform that as scheduled for bandwidth reasons. For your next portion of the flyby, in particular the Eclipse, we want to remind you that you can take off the Eclipse glasses when the sun sets and you are simply looking at the corona. And then finally, for the D5 with the long or zoom lens, which is set for solar corona.
Yeah, I'll be back,
We wanna
guys.
remind
I
you that
wanted
when you
to
are
check
capturing
on my
Earth
scope
shine,
and I'll be back.
you will
I'm
likely
not
have to
muting
adjust
them.
the
I'm only
exposure.
muting
That's all I have
my
for you.
cam.
Let me know if you have anything for us.
Okay, Houston, we copy all. Thanks for those words, Jenny.
All right, just a quick call up to the crew ahead of a forward link LOS, meaning that we won't be communicating with them, but we will be receiving their communications and data during that time frame. So, Angela, we were talking about analog environments. You were telling me about the classroom and getting in there and pretending who's Victor, who's Reed. Tell me more about this.
yeah, it works pretty well. So you're gonna do the plan how you expect it to be, and then once we finalize that plan, we'll give it to a completely new group of people and have them practice it, and then they'll be like, these steps don't make sense, and we'll reiterate on it over and over. Then we'll take it to a higher fidelity environment like the Orion mock-up, and we'll do the same thing because that volume is smaller, the window placement, their seating, what things have we forgotten with this addition of this environment. And then once we reiterate on that, we'll take it, then we'll give it to the crew and have them execute off of it during mission simulations. That's the highest fidelity that we can do before we send it to space. So this is the first time we've had to do this because we're a brand new console, and it just sparks so many neurons of like, how are we going to do this for surface missions and integrate this in so many different ways. So excited to have kicked off this process, but there's so much more to come.
Fascinating. And I think it was really well thought out too, because each crew member gets an opportunity to do each task. And so you're getting different perspectives and different insights from each crew member, maybe even about the same target, but something that one person sees could be completely different than something another person notices. So we also know that Artemis 2 has traveled. They're now on their way home, but they traveled farther from the moon than the Apollo missions did. So what makes that vantage point scientifically interesting?
Yeah, observations are so fundamental in the scientific toolkit, particularly observations from different perspectives, different scales, and with different techniques. And so we really tried to make the plan to optimize those there's pros and cons for all those things for this mission. So we really just focused the plan to have all those pros. So in terms of scale, this zoomed out scale, you can learn different things. This different perspectives. So their perspective, as Kelsey talked about, photometry around when they orbit the moon. And then also just their different the different things they're able to observe. So yeah, let me talk a little bit about scale, because I think observations at different scales, you can gain a lot of different information. So like, for example, if you were an astronaut on the surface looking at a rock, and you describe at this micro scale. So in training, we kind of talk about observations from micro to macro, or from outcrop to orbit. So looking at, a rock at this scale, you can describe its components, you can describe what it's made of and its colors and its minerals. And you're like, okay, and this rock came from this boulder, and it's this part of this boulder, and these are the different things that I'm observing around. It gives me context to this sample. And then you zoom out a little bit more, and you're like, okay, well, I can see that this boulder came from, it rolled from this mountain ridge, or this high ridge feature. And then because I can see the trail that it came from, okay, now let me describe this ridge, and different parts in it, and maybe other boulders that I'm seeing. And then you zoom out further of the orbit scale, and you're like, this ridge is a part of this larger crater. So all of those different steps give you different information, and so that's why observations at these different scales and these different perspectives are so important. So this zoomed out kind of far view is this full lunar disk view. It's the full lunar. On Earth, we see the full lunar disk as well, but now we're able to see it on the far side, and we're able to see it, all at the same time, which enables the astronauts to compare very quickly to different parts of the surface. And the color particularly is very compelling, because you can just be able to very quickly compare from 3 different regions. Is it in the same family? Is this actually a little bit different? Compare that to what they see in their orbital data that they have access to on their portable computers, and really just be able to tease out that nuance and information.
Yeah, we heard them make a lot of those connections today, and especially the color. We talked with Kelsey about this a little bit, just how exciting it was to hear the browns and greens and things like that. I cannot wait to see those pictures. Yeah. So one last question. We are coming up on the last lunar flyby observation block, and this is when we are going into a solar eclipse. So can you tell me what you're interested in the crew learning during that time frame?
Yeah, so the data set. So yes, there's so many things. How to pick one. So I'd say the thing that I'm most interested in seeing is some of their annotations that they're taking. So in this opportunity, it's a very dynamic type of experience, in that we don't normally see this activity. And so being able to have crew observe the solar corona, and then also annotate it in their on their portable computing device is just such a unique thing that humans can give to missions, and also particularly being able to annotate what they're observing while they're talking about it is also unique to being able to have astronauts in orbit as well, because we won't be able to have annotations on the lunar surface, because the astronauts will be in suits. They're going to be collecting samples, they're going to be deploying instruments. And so personally, I'm really excited to see some of these annotations and to see how that develops over time, because you've heard a lot of descriptions, and I think when people are describing something that's unique and different, you can interpret it differently. But if you're drawing and you're marking, particularly just going back to like the color provinces, for example, and those boundaries, you know exactly what they meant. And really, I'm just very excited about those annotations. There's been some famous annotations that the Apollo crew have made, particularly about solar coronas and the structures that have, and lofted dust that have given a lot of debate within the scientific community of they're observing this phenomenon, and now it's our job to hypothesize of like, why are they observing this? Like, what is what is going on. So I think that's just a really cool part of exploration and science, and this beautiful thing that we're about to do.
Well, now you've got me excited about the annotations too. I mean, I've been excited about the pictures and the audio, but now
Don't sleep on the annotations. I am very excited to see these little sketches that they're able to draw out. And we have pictures that they can just draw right on as like, this particular thing is different than what we've seen. So I'm excited about that.
I'm excited too. Angela Garcia, thank you so much for joining us today, and have a great time tonight on console.
Thank you. And you've been doing a great job, and it's so excited to see where we go from here.
Thank you so much. Integrity Houston, you have 3 minutes until we go into a forward link LOS. We will be back up with you in about an hour during the eclipse on Madrid.
Thanks for the heads up. Look forward to seeing you on the other side.
Likewise.
We're live in Artemis Mission Control at Johnson Space Center in Houston, Texas. This is a live view from the Orion spacecraft with our Artemis 2 crew inside. That's Reed Wiseman, Victor Glover, Christina Cook, and Jeremy Hansen. We are still live for our lunar flyby coverage. The crew is in a short break while the spacecraft is pivoted away from the moon. We are going to be going into a solar eclipse. This is the first time anyone has ever seen a solar eclipse from the moon. So it's going to be a unique vantage point for our crew. But ahead of heading into that solar eclipse, we need to charge the batteries on the Orion spacecraft. Therefore, we have positioned the solar arrays into the sunlight to allow time for those batteries to charge. We will get back pointed at the moon just in time for that solar eclipse. We are also in a forward link LOS. What that means is essentially we cannot send calls or commands to the crew right now from the ground. However, we clearly get all of their data and communications. The spacecraft is now 4,632 miles away from the moon, and that number will only continue to grow as the distance from Earth shrinks, now 252,523 miles away. Our closest approach to the moon today was approximately 4,067 statute miles in altitude. Our maximum distance from the Earth is suspected to be 252,756 statute miles. Both of those moments came while Orion was flying in their loss of signal time frame behind the moon. The crew also set that new record today, beating the Apollo 13 record of distance from Earth. This is an animation or a visualization that you can track anytime, day or night, by visiting nasa.gov/track Artemis. This shows you how the spacecraft is positioned as well as their distance and velocity, now traveling 930 miles per hour. During this break in their time today, the crew is working on a couple of other tasks. Some of those include their National Geographic timeline test. National Geographic was selected through a competitive process by NASA to help tell the story of Artemis 2. So you've seen the crew with some GoPros inside the cabin, taking videos and pictures, and with other cameras as well. National Geographic plans to leverage its portfolio of media assets, including magazines, social and digital content, and television programming for engagement opportunities. Throughout the flight, the crew has been timelined a little bit each day to film from a shot list provided by National Geographic, and that includes their morning routine, talking with their families, exercising, and just their overall thoughts about the mission. And I cannot wait to see that footage. Teams on the ground reporting that the spacecraft is looking good and that the power aboard is good as well, all setting us up in a proper position before eclipse. The formation and evolution of our planet and the solar system. Let's learn more about the lunar South Pole with this video featuring Dr. Kelsey Young, Artemis Science Flight Operations Lead.
We learned a lot from the Apollo samples, but we still have a lot left to learn about the moon. The Apollo missions visited only a pretty narrow swath of the moon. All the missions were concentrated near the near-side equator. Really interesting and really critical insights were unlocked with the Apollo samples, but we have so many questions still to answer about the moon and the evolution of the moon.
And liftoff of Artemis 1. We rise together, back to the moon and beyond.
NASA's Artemis missions are NASA's plan to send people to the surface of the moon. We'll be sending people and roving assets and scientific equipment to, among other things, answer a lot of really compelling science questions. Scientists have a lot to learn about the moon. It's our nearest celestial neighbor here to Earth, so what the moon has experienced, we've experienced. Except here on Earth, we have things like plate tectonics, oceans, forests, people that erase the rock record. Whereas on the moon, that whole record of our planet's history, of the moon's history, is just kind of waiting there at the surface for us to explore. The South Pole, which is where Artemis missions are going to target, is specifically interesting for a couple key reasons. We think there are volatiles at the South Pole of the moon that are not present near the equator. Things like water and water ice that are trapped in the lunar regolith, which basically just means lunar soil, that can easily become untrapped from that lunar regolith, and scientists can scoop up and study for return to Earth. The lunar South Pole is a really exciting scientific target, and it also comes with some challenges for operating. For example, the lighting environment will change drastically within the course of one mission, and even over sometimes the course of one spacewalk. So preparing the crew members, preparing the hardware that we're sending to the moon, and preparing the mission control teams is really, really important. The South Pole Aitken Basin is particularly exciting. We think it's one of the oldest and largest impact basins in the solar system. And if we can get the right rock from the South Pole Aitken Basin and bring it back to our labs here on Earth, we can use that sample to constrain the entire evolution of our solar system and really understand the timing of how the moon and our planet and the entire solar system evolved.
You're looking at a live view aboard the Orion spacecraft of the Artemis 2 crew, working in the middle of one of their breaks, or really their only break today during this lunar flyby period. Coming up next will be that solar eclipse. Throughout the Artemis 2 mission, and of course throughout today, you've likely heard the crew being called with the name Integrity. The Artemis 2 crew members named their Orion spacecraft Integrity during a news conference September 24th, 2025. The name Integrity embodies the foundation of trust, respect, candor, and humility across the crew, and the many engineers, technicians, scientists, planners, and dreamers required for mission success. They said this name is also a nod to the extensive integrated effort from the more than 300,000 spacecraft components to the thousands of people across the world that must come together to venture to the moon and back, inspire the world, and set the course for a long-term presence at the moon. The crew also said that integrity is rooted in a shared core value of NASA, the agency's astronaut office, and the CSA, the Canadian Space Agency.
that's why I said I'm not going. So anyway, I did set up that telescope over there, which is really, really good. So we will start playing around with our own scopes to see where these people are. Looking forward to. Yeah, it took a little longer than No, I'm not muted. I'm still talking. Okay, so yeah, I'm not. It took a much longer than expected because of the rain. There is so much fog on the screen of the telescope, like on the mirrors. So I have to use like, what do we call that? The hair dryer to make it little warmer.
We are 5 days, 1 hour, and 38 minutes mission elapsed time into Artemis 2. In this view on the screen, you can see the crew starting to even look through some photos that they may have captured today. We really look forward to sharing these photos with you as soon as we possibly can. And the best way to keep up with those is to follow NASA on social media. You can do so
my
at
goodness.
NASA,
Thank you.
and for this mission specifically at NASA Artemis.
Thank you. You made my day, Scott. Thank you. Yeah, I have to go and clean that front mirror because it's not cleaning necessarily, just making it warmer, I would call it. So Scott, we will try. I believe you are giving me the...
Again, we are in a forward link LOS, or forward link loss of signal with the crew, meaning that we're not able to communicate or send any commands to them right now as they were. This is a tracked event that occurs at times, but they could still provide communications down here to us, and we are obviously still receiving their video and their data.
Yeah, essentially what we are trying to do now is try to make sure that we are in fact tracking this. So there is a place where you could see this is happening. So we just need to see where that is. Oh. It's kind of everyone goes on mute same time or everyone talks same time. Hold on. Thank you very much for your support. Yeah, I don't use the space heaters, Glenn. I need to build the whole thing, then I can control the weather inside. Right now, the weather inside is pretty much outside weather because I did not build the whole thing yet, but we eventually we'll get there. It's not only taking time, but also it is just adding too much from everything else, right? So we just need we are trying to go to the live event of looking at this
Houston Integrity
Artemis mission on the telescope.
Activities on Reed's timeline are on PCD1 in a folder imagery for downlink, and then high priority standby imagery for downlink, and then lunar flyby for PAO, and then high priority PAO. Thank you.
So I left the other window up there so that you can see what I'm working on while this is going here. The tablet that is not floating, oh no, they stuck their tablets to their legs. There is a belt.
This is Artemis Mission Control. You heard Reed Wiseman, commander of the Artemis 2 mission aboard Orion, make a call in the blind. This means he knows we cannot call back and that he knows we may not receive his call. However, we have good communications with the spacecraft. They just cannot hear from us right now due to a forward link loss of signal. Again, we were tracking that this would occur, and we will regain that momentarily. But that call that came down from Wiseman mentioned some imagery, so we are very much looking forward to getting pictures taken from the moon today. Again, to see those images, make sure you follow NASA on our social media at NASA and at NASA Artemis.
So I'll be back, folks. Give me a minute. I'll go in and out pretty much from this point onwards because I do need to figure out what's going on there. So I'll be back in 1 minute. Oh yeah, definitely. We need to set up the cameras first. I'll turn off.
The view on your screen right now is an animation. This is called Arrow, or Artemis Real-Time Orbit website. You can visit this for yourself at nasa.gov/track-Artemis, and you can watch as we continue to grow closer to Earth and farther away from the moon. It's all seemed to happen so fast so far, and we're coming up on splashdown now in 3 days, 23 hours and 31 minutes.
So I do wanted to see what is going on out there. So I did move the
This is Artemis Mission Control. We are in a forward link LOS with the spacecraft. We're not able to send commands or communications to them right now. However, they could send them to us, and we do get spacecraft data. This is tracked as we are on the Deep Space Network. This is the network that we use to communicate with the spacecraft now that we are so far from Earth, over 252,000 miles. We are still in our lunar flyby coverage. The crew still have a very important and very exciting flyby milestone coming up when they will see a solar eclipse from the moon, the first humans to ever do so. Something that we also have to consider when it comes to our missions and launches is space weather. So since the Apollo 16 and 17 missions, there were some solar eruptions near that time frame that could have been dangerous to our explorers. Over those 50 years since those storms, the data, technology, and resources available to NASA have improved, enabling advancements towards space weather forecasts and astronaut protection, which is key to NASA's Artemis program to return astronauts to the moon.
Yes.
Across our planet, billions of people depend on the invisible networks that connect us to space. Every day, those networks are at the mercy of our temperamental sun and the space weather that it unleashes across our solar system. That's why NASA's space weather program tracks solar storms from the moment they erupt, modeling their paths, anticipating their impacts, and leading the research that the world's industries rely on.
Oh my gosh, Hank looks so cute right now.
NASA's space weather research and modeling is driven by the needs of society and enables critical decision-making that equips pilots to reroute around high radiation areas, farmers to adjust GPS-based precision planting and harvesting plans, and power grid operators to mitigate the impacts of potential surges. For those exploring other worlds, NASA provides 24/7 space weather monitoring for Artemis crews at the moon and future Mars astronauts who may be exposed to dangerous levels of radiation during solar storms. Whether you're a pilot or a passenger, a farmer or a consumer, a power grid operator or energy customer, a satellite controller or GPS user, space weather impacts us all.
This is a live view from the Orion spacecraft on the Artemis 2 mission. It's now been 5 days, 1 hour, and 54 minutes since we launched. We are still in our flyby coverage, and the crew is on a short break right now as we have changed the attitude of the spacecraft to help charge the batteries aboard. We use the solar arrays to gather energy from the sun and store it in the batteries. That way, when we are not in the sunlight, we have those batteries to continue powering Orion. Now, we're doing so because the Artemis astronauts are about to experience a solar eclipse from their capsule. And this is a solar eclipse that no one else on Earth will experience. This eclipse is about 54 minutes, and to the astronauts, it'll look a lot like a total solar eclipse on Earth, except the moon is going to be huge compared to the sun, unlike when you watch one on Earth and the moon and the sun appear about the same size in the sky. We're interested to learn if they see the outer corona when the sun is fully obscured by the moon. And because of how big the moon will be from their perspective, the total phase of the eclipse will last nearly an hour. The astronauts will see a partial solar eclipse as the moon covers and uncovers the sun, which is before and after totality. So, much like us on Earth, they will have eclipse glasses so they can safely view that portion.
Wow, wow.
The astronauts will also be using
Folks, I'm
cameras
going to
capture
turn this
images
off.
of the corona during the eclipse.
I don't want you to miss it. I don't want you to miss it. The eclipse is coming.
There also may be some other planets visible during the eclipse, including Venus, Saturn, Mars, and Mercury. If they can identify what part of the sky they're looking at, this can help train future Artemis astronauts on what part of the sky they're seeing. This provides useful knowledge in challenging situations when they may need to rely on that information instead of instruments for navigation and orientation.
This is one of the best moments, folks. I can't believe it. I know I'm going in and out, but it's been one of those long streams that I did after a very long time. I did this back when I was capturing the 3i.
Confirmation from
Oh
teams
my
here on
God, look
ground
at the
that
sun.
We have reached the eclipse attitude, meaning Orion is in the proper position to observe it.
So, wow. We can't see much because of the glare that is coming
The
out.
astronauts' break during this observation period is now over, and we are resuming their lunar flyby observations. The first of these is sunset. This is the solar corona that we'll be looking for. It's the outer atmosphere of the sun. The science team is also interested in if the astronauts can see polar plumes. These are thin streamers that project from the sun's north and south poles. Additionally, they're interested in seeing if the crew can witness coronal loops. These are arcs close to the sun's surface. And something else that we've previously mentioned is lunar dust. This is dust from the moon that is lofted above the lunar surface and illuminated by the sun. It was reported visible by Apollo astronauts.
Interesting. So we actually never had a person looking at this, like human beings looking at this planet for a long time. Or you can call it moon for a long time. And now we are, whatever they reported 50 years back, they are checking it now. That is sad. But that's the truth. That's the truth. We are seeing plasma or plumes. They are talking about, oh, I'm not on the camera. Hold on. What happened to my camera? So they are talking about the plumes coming out of the moon's north and south poles because there is ice out there. And also we wanted to
Orion spacecraft on the Artemis 2 mission. Orion is now 252,125 miles away from us all on Earth. We're here in the Artemis Mission Control Room in Houston, Texas, and what you had just before we lost that view quickly was the corona of the sun peeking around the moon as the astronauts are entering a solar eclipse for this portion of.
I'm Rand Spear, the accident lawyer. I've earned my reputation and I'm proud of it.
500 statute miles from the moon. That closest approach today was just about 4,067 statute miles away. And teams in the room beginning to get a little busier and filter in and out as we are stepping through a handover. The Orbit 1 team is handing over to Orbit 2, who will continue monitoring lunar flyby and all of the systems aboard the Orion spacecraft.
My goodness, that's unreal, folks. That is unreal. It's just one tiny star or a planet somewhere that looks to me like a planet.
You're getting your last few views of the solar corona as the moon begins to take center stage and completely cover the sun. If you see that bright dot up near the top left of your screen, we think right now that that may be a part of the spacecraft, but we'll be sure to correct that if we end up figuring out later that it is something else entirely.
Yeah, they also don't know whether that is a spacecraft, that tiny star, or a star or a planet. So they are also trying to eagerly find out what's happening there. That's very interesting. It's been a very, very long life.
It has been an absolute honor to join you here today for the lunar flyby of Artemis 2, the first time humans have flown by the moon in over 50 years. I'm Leah Cheshire Mustachio, and I'm excited now to hand over the
team is shifting around in the windows, and we are transferring settings on the camera to pick up Earth shine, and it is amazing. The brightness where the corona, where the sunset is still bright. I think there may still be corona visible, but that part of the horizon is still lit brighter, and you still have a distinct Earth shine.
You know our rules that we don't talk when the crew is talking, so wanted to give Victor Glover a moment there to call down what he was seeing now that the moon is covering the sun. A really amazing time during today's lunar flyby. Again, thank you so much for letting us help tell this story today. I am Leah Cheshire Mustachio, handing it over to my friend Anna Schneider at the PAO console as the Orbit 2 team comes to join us. So thank you so much, and I hope you all enjoy tonight. Anna, you can take it away.
Thank you so much, Leah, and it's been a joy listening to your coverage over the last several hours. So as you mentioned, the Orbit 2 team of flight controllers is currently making their way on console and completing a shift handover with the Orbit 1 team of flight controllers. The Orbit 2
Stephen,
team
yeah, it
tonight
could be,
will be led by
it
Flight
could be
Director
Jupiter,
Diane
yeah,
Daly,
that's what is
and she is
nearby.
currently handing over with the Orbit 1 flight director there on your screen, who was Flight Director Jeff Radigan.
I'll be back, folks.
The Artemis 2 crew currently on board the Orion spacecraft. It continues to observe the eclipse that they are witnessing. There's about 43 minutes remaining in that eclipse period. This is Artemis Mission Control. You are currently seeing a live view of the solar array wing cameras on the Orion spacecraft. We spoke with our science team, and they did determine that that dot in the distance is Venus.
Science integrity. Let's see, not a huge change in here, just an update. The camera settings for Earthshine are challenging. This one's challenging to capture. What we're seeing, we're just not picking up on the cameras. And after all of the amazing sights that we saw earlier, we just went sci-fi. This has, it just looks unreal. You can see the surface of the moon between, I guess, the Earthshine. I guess Earthshine. You can actually see a majority of the moon. It is the strangest looking thing that you can see so much on the surface.
This is Artemis Mission Control. You were just hearing some communications called down from NASA astronaut Victor Glover, currently on board the Orion spacecraft. They are currently observing an eclipse. There's about 39 minutes remaining in that eclipse period. Currently, we are in a forward link LOS, or loss of signal, so the crew can communicate down with...
Reports he's seen 2 meteors, science.
So we are in a forward link loss of signal. We do expect to regain signal in about 3 minutes. And at that point, then the ground can communicate back up to the crew on board the Orion spacecraft. In the meantime, the crew can continue to communicate down to the ground. The ground is just unable to respond. So they are continuing to provide some science observations during this eclipse period. They've made some comments about Earth shine, which is the sunlight reflected from Earth when they come around towards the moon's near side late in this flyby window.
Hey folks, I just wanted to make sure so I do have some connection issues that I'm dealing with. So
integrity in the blind. The glow around the moon is beginning to become a little bit more even. It's not so much distinct just where the sun set on the moon's horizon as we're flying through this trajectory, and then the sun's going to come up out of the other side. I think it's we're starting to see the glow around the moon get balanced out. I still see Earth shine, and the Earth is very bright out there. Still quite an unreal sight.
Integrity Houston, we have that sit rep loud and clear, and we are back with you. How do you hear me?
Hey, Jenny, we have you loud and clear. Thanks.
Copy. Victor, we're handing you over to Science for some critical questions. Thanks for your report. Integrity Science, we were loving your science sit reps in the blind, and it should come as no surprise that we have a number of follow-up questions. First, you mentioned Reed observing meteors. Can you speak to that? Were you referring to comets or impact flashes or something else?
Yeah, there was a little bit of giddiness. We have seen 3 impact flashes so far.
When a relationship is new, everything flows. You got the girl, you hung the moon, you're ready when the wind blows. But life keeps going. Bills, carpools, shared calendars that need their own calendar. Suddenly, romance has a meeting reminder. We can't pause time, but we can crack a window. Blue Chew Gold combines 4 powerful ingredients for connection and intimacy. The spark didn't die. It just needed a little air. Blue Chew Gold.
Before I started using the farmer's dog, I would fill my dog's bowls up with dry kibble in the morning, and they would just kind of walk by and pick at it all day. After we switched to farmer's dog, they cannot wait to eat. My golden retriever is 6 years old, but the way she used to act, you would think that she was 9 or 10. Switched to a farmer's dog, and her energy levels up because I know she's getting the nutrients she needs. Farmer's dog is human.
All right, so Jeremy has seen them kind of on and south of the equator, kind of spread across the moon, and mine were both south of the equator and just a little bit left of center of the moon.